Now for this guy, I know a sub 1, and I know a sub n, and I know n. And if I look at the formulas for arithmetic sequences, this is going to be n over 2 times a sub 1 plus a sub n. So if I know the first term, if I know the first one and the last one, and if I know n, this is the formula that I want to use. Any money that falls on the floor is mine. All right, so let me reiterate that with my wonderful messed up voice. If you know the first term in the series, and if you know the last term in the series, this is a formula you're going to want to use. Because it has n, which we know, the first term and the last term. So it has everything that we need. So I know n is 14, so it's 14 over 2. And then the first term's 42 plus 146, which is the last term. So that's going to be 7 times 188. 56, carry the 5, 56, 61, carry the 6, 1316. So if you have the first, the last, and n, this is what you're going to want to use. And that's the formula you're going to want to use there. All of these are just picking out which formula is the right formula to use. Now, anything else on the first page? Yeah. Number 7. All right, number 7. There's a rule that says when you have a number times the variable, you could take the number and put it in front of sigma. So it'd be 4 times the summation from m equals 1 to 15 of m. So I have 4 times this guy, which we have a rule for. So we have a formula for this guy. So we go to the wall, take a look at the wall, and so this formula is 4 times, well, the formula is n times n plus 1 all over 2. That's what the formula is. So I have 4 times that. Now what's my n value? Yeah, n is equal to 15 because that top number there is n. So it's 15 times 16 divided by 2. N and n plus 1, so it'd be 15 times 15 plus 1. So that's where we got our 16 from. Now, in this case, 2 divides into 16 8 times. So that's going to be 40. So 4 times 0, carry the 4. 8, that's 120. So 480. So we got an answer of 480 out of this one. I'm making them right now. They should be up before the end of 5th hour. All right, backside here. Sure. Now, this is a test type of problem too. I know a sub 1 is 7. Now, I know n right here is 10, and I need to figure out d. d is a sub n plus 1 minus a sub n. So I need to take a term and then subtract the term right in front of it. And since this is arithmetic, that's what we're going to happen here to find the common difference. So I can take the first two. 9 minus 7 is 2. So I know D is equal to 2. So I'm now going to use the summation formula. S of n is equal to n over 2 times 2 times a sub 1 plus n minus 1 times d. Now my n is 10, so I'm going to get 10 over 2. 2 times a sub 1, which is 7, plus 10 minus 1, which is 9, so I'm going to put a 9 there, and then d is 2. So that's 5, it's 14, plus 18, so it's 5 times 32. We're running out of a little bit of space here. And 5 times 32, 5 times 2 is 10, carry the 1, 15, 16, 160. Yeah, and the idea is if I took 13, I need to figure out how do I go from 11 to 13. And that in order to get there, since it's arithmetic, which means A for arithmetic, A for addition, so I know I got to add 2 to get there. So that's what my D is going to be. You add 2 to get there, you add 2 to get there. Number 23. All right. Now, this is a test problem too. In as much as we're going to have to solve these equations for different variables. Now, it says the question is determine the number of terms in each series. So I need to figure out what the number n is. Now here I have a sub 1, d, and s sub n. And the one formula that I'm going to want to use in this case, and I need to get a little bit more paper here. I want to use S sub n is equal to n over 2 times the quantity of 2 times a sub 1 plus n minus 1 times d. Because I don't know what my n's are, but I do know what a sub 1 and I do know what s sub n is, and I know what d is. So I'm only missing one variable. So if I solve this for that one variable, we're good to go. So let's just go ahead, plug in s sub n, which is 21. That's equal to n over 2 times the quantity of 2 times negative 3, because my a sub 1 is negative 3, plus n sub 1. I'm going to leave that guy alone as much as possible, just because I don't really want to deal with that too much. And then my d is 2. Alright, first off, what I'm going to do is I'm going to multiply both sides by 2. And the reason is I divide that 2 into that 2, and I'm left with just an n. So I'll get 42 is equal to n times the quantity of negative 6. Just did the multiplication there. Uh-oh, factoring here, maybe. Plus 2n minus 2. We might have to do some factoring. That's no fun. Alright, so in this case, I could simplify it a couple more steps. 42 is equal to n times the quantity of negative 6 minus 2 with 2n minus 8. And that just meant taking care of those two guys right there. So now distribute, because I have an n on the outside, n on the inside. I can't do anything. The only thing I can do is distribute. So we're kind of stuck going into the quadratic realm here. So I get 42 is equal to 2n squared minus 8n. So now, to make our lives a lot easier, subtract that 42 from both sides. Get 0 is equal to 2n squared minus 8n minus 42. Because now we have to solve ax squared plus bx plus c equals 0. And a big way of doing this is factoring. So if you guys forgot how to do this, it's a tool in your toolbox that you always have to have. The first thing when we're doing factoring, is there a common factor? That's your first question. Is there a number that divides into 2, 8, and 42? What's the number? 2. So I could divide that by 2, divide that by 2, divide that by 2, divide that by 2. So if I divide everything by the same if I divide everything by the same number, we could get this into an easier state. So 0 is equal to n squared minus 4n minus 21. So that's a little bit easier to deal with. Now, do I know two numbers that can multiply together to equal negative 21, that when I add them together, they're equal to negative 4? Yeah, negative 7 and 3, negative 7 and 3. Alright, so 0 is equal to n minus 7 times n plus 3. So I take this guy, n minus 7, set it equal to 0. Take this guy, n plus 3, set that guy equal to 0. And then add 7 to both sides, so n is equal to 7, or n is equal to negative 3. Now, at that point, we need to make a determination. This is getting bad. We need to make a determination which n is the actual answer. So the question, think about what the situation is. N is equal to the number of terms. Can it be negative? Can you have negative 3 terms in a series in a sequence is basically a list of numbers that are linked together by a common difference or a common ratio. So, can you have a negative number in your list? Yes. No. You can have a negative number in your list, but can you have a negative number of items? That's what I meant. So technically you were correct. I asked the question poorly. Can your list be negative 3 long? No. So no. So this one I'm going to get rid of right away. And so n is equal to 7. And so there's 7 terms in this problem.